like all good consultants, he's always very busy. And on that, I'd like to say it's a real pleasure to have you here today, especially with your discipline. It's someone we look to. You've written plenty of papers. They're very, very informative. The gentlemen, would you put your hands together for Colin Cass?
Usually get more than that. Thanks very much for the invitation to be here. I've brought along my offsider, Chris Repeti, who's helping me out with a number of the workload that I've got. It's really quite good to be here. I haven't spoken to this group for a few years now, and what I'm going to try to do is see if I can focus on things that would help building consultants not get into trouble. Right? So if we can get things right and not get caught out, then you're going to be in a position to have less grief, and so we'll just sort of carry on with that, which should be that one. All right, so that's the outline of what I'm just going to say. Halfway through, Chris is going to take over. His expertise was also in tiling, but also in stone and stone cleaning and management and stain removal and installation. So half of this will be me and half of it will be Chris. Wrong button. There we go. Are drummy tiles always a defect? And I've written a paper on it. It's out there. I think you can probably Google it or something. It's changed just slightly. The Guide to Standards and Tolerances 2017 removed the percentage of drummy tiles relating to a defect. Remember, the 2002 version was, I think, 10%. The 2007 version was 5% of tiles. If more than 5% of the tiles are, then it's a defect. And that's a bit of a nonsense, because there are different types of systems that would mean 100% of the tiles are loose, right? So it's now saying that any tiles that are loose within 24 months is a breach, right? Now, loose is a bit of a loose term, and under the Australian consumer law, I think you'd be actually able to go those people for 5 or 6, 7 years. You say, look, if I put tiles down, I expect them to stay down for longer than 24 months. So I think that it's fair to the consumer that you be able to override that by saying, well, we expect these things to last longer. Australian consumer law, if you buy a fridge and it breaks down after 3 years and it was a 2-year warranty, you can go back and say, I expect a fridge to last longer than that, and you'll win. So it's important, I think, for building consultants to understand the tiling system. I did have one recently where they said all the tiles in the kitchen were drummy. It was an apartment and there was an acoustic mat underneath, so 100% of them were drummy. But they were all solidly bonded and performing perfectly. The grout wasn't cracked and there wasn't a real issue. But he looked like a bit of an egg when we explained to him that there's an acoustic mat underneath it. And what you need to do is assess the tiling system, look at the location of the movement joints, look for cracked grout, look at the location of where things are drummy or the like, because if there are movement joints aren't working movement joints, so you can put a pin down them and all the rest of that, then the strain that the system is under is not going to be relieved by the movement joints, and so therefore latent damage is likely to occur. Whereas if the movement joints are working, so well, it should be being relieved and it might survive. So the traffic, I mean, if it's a very light area and there's a couple of drummy tiles behind the door, or maybe it's not a real big issue. If it's right in the middle of the doorway of somewhere busy, chances are it's not going to last its life. So one of the things I mentioned in there was crack isolation mats, and these products are now coming out from about 4 or 5 companies in Australia now. There weren't any when I first kicked off with this, and I'd see them in Europe, and they were widespread, being used for 30 years. America, all those timber frame houses, upstairs timber frame floors, they put this down so that the bathroom floors don't crack. And there's a range of them out there, and we've got a couple of samples I'll show you here. But sometimes if you're in a position, you say you've got a badly cracked floor, you say, oh, we're going to replace it. Well, what's the use of replacing it? Because the next one's going to crack anyway. So these crack isolation, if I get a chance, I'll explain to you how they work. They are exceedingly effective. We've tiled over old movement joints going in different directions. So, for instance, Sydney Airport, Warriewood Mall, a few other places. The old tiling had movement joints at different places. We just put down the mat and put the new movement joints in. So it's able to take up things that you wouldn't be able to. Outside on decks where hardies are saying you've got to have a movement joint between each sheet of compressed fibro, you can put this stuff straight across and you don't have to have a movement joint at every joint in the fibro. So it's a bit of technology that's taken a long time to get to Australia, but I think it's going to get a pretty good take-up. So what you need to do is assess the causes and record the location, number and pattern of the drummy tiles. And what I do is I call it undertaking a condition survey. You can't do it on all great big jobs. You might do a sample in a shopping mall. I might do 4 bays or 5 bays, and I'll mark out every tile on the grid, and I'll mark which ones are drummy. And then you're in a position, as this dispute goes on, to go back in 3 months' time or 5 months' time and go, guess what? It stayed exactly the same. Or guess what? It's spreading. You've got a line in the sand that you can take a measurement from. So doing a condition survey is sometimes worthy if you're going to be fighting over drummy tiles. So record the location and whether the movement joints are adequate, and if you can, establish if levelling devices were used. Now these things are becoming much more popular. As the skill of the tile layers is going down and the surfaces they're going over are getting a bit rougher, and as the tiles are getting bigger and bigger, and the complaint is becoming lipping and lipping, these little devices go underneath the edges of the tiles and they have a little jack and they just pull the tiles up. So the levelling device pulls 2 tiles at the corner to make them flush with the neighbours. So you put them in along the like that, and you can see in this case the little white thing sticks up. Underneath it, it's got a couple of feet. So the white thing sticks up, the wedge goes in underneath, it pulls the bottoms of the tiles up to make them flush on the top. The trouble can be that if they're activated after too long, let's say the tile lays 20 metres, then we might end up pulling the adhesive up and debonding part of the tile. So I'm now seeing a couple of jobs where we get a particular pattern of drumminess, and that drumminess I can relate to them lifting the corners of the tiles to make them nice and flush. So here the concrete in between 2 rooms in the doorway, and where those yellow crosses are, the tiles had spaces underneath them and they were lifted up, and it just seems like if that was the low corner and it got pulled up after it had set a bit while the adhesive wasn't plastic, then you'd end up with some drumminess. So if you decide that the tiling has got drummy tiles in it and you think it's a defect, you also then need to consider your options. So you might say, oh, well, I found drummy tiles, and they are drummy tiles, and they're likely to fail in the future, and so it is a genuine defect, and I'm not going to be saying that it's not a defect. But what are your options when it comes to rectification? And I think if you go before a member of the tribunal and you can say, look, I've got a way of doing this that is less expensive than complete removal and replacement, and it's willing to be guaranteed or warranted, then let's look at it. And so we can get injection with some companies will come around and drill holes and pump liquids underneath it. The first one I did was out at Orange 15 years ago at least. Absolutely no worries. It's rebonded the tiles and there isn't an issue, right? So that could be all right. Remember that if there aren't enough movement joints, you're probably not going to get an award to rip the whole thing up and put it in with more. You'll probably get an award to turn around and retrofit some movement joints. We can cut most of those in later and ease the strain that's on the tiling. So if I've got drummy tiling and there aren't enough movement joints, or the movement joints have been blocked by cement, or they're those fake ones where they just filled it up with grout but then wiped a little bit of silicone over the top to make it look like a movement joint, then we can come in and retrofit some of those and put it back inside code and probably save the tile from the tiling system from stress later on. And it's also sometimes important to know if there's any spare tiles. So ask the question, because if they've got spare tiles in the garage or whatever, you know, all right, we can break a few, we can fix this up. If we haven't, then sometimes it becomes a bit of a bigger issue. So there's just a shot of one of the people that do this sort of stuff. There's now quite a few, and it's becoming a popular way of rectifying drummy tiles. Now, just a couple of quick slides on another one that I'm finding a lot of, and that is building consultants go inside, they put the level down, they find that the fall in the bathroom floor isn't 1 in 100. So it's outside BCA. And they go, bang, defect. Right. Just think about it for a little bit, because the BCA is a performance-based document, and it is quite strictly laid out. I know we'll have a bit of a fight, and I think this is actually worth a discussion amongst the group as a whole, membership input research argument. But the only mandatory requirements are the performance requirements, and that was put out very clearly by Graham Moss. And I'll let you read what he's got up there if you can read that. Ed wants me to read this out. So there are rules in the code that say yes, the mandatory requirements are the performance requirements. You can achieve that by either meeting the deemed to satisfy solution or another performance solution, but the only mandatory requirements are the performance requirements. So you've got your functional statements and you've got your objectives, but the performance requirements are what you really need to look at, because they're the mandatory bits, right? Now, I'm going to go pretty much in a second onto one that's not a mandatory bit that we've got to do something about. But so it seems like it's talking against myself, and that's why I think it's a controversial thing that should be broadly looked at. On that last slide, there was if you Google up Graham Moss and the Australian Building Codes Board, you'll find that full extract of his speech which outlines all of that. So calling for a floor to be replaced because it's not 1 in 100 will rarely succeed unless we've got an exit, unless we're breaching the code somewhere, water's getting out of the room, etc. And the other thing is that seeing a floor that's less than 1 in 100 and going, okay, we're going to replace it. Well, if you replace it and the floor waste happens to be 2 metres away from the doorway and you put your 1 in 100 in, you're coming up a higher 20 mil at the doorway. So you've got away from a defect, theoretical defect, that doesn't really have a big impact on people, to give them a trip hazard at the door that they'll hate for the rest of their lives. So, it's kind of a common sense thing to put on some of those issues. Ponding's not defined, and we've had this out. I've published papers on it, I think back in 2002 was the first one. We had a talk in the Australian Standards Association in committee, on both the waterproofing committee and on the tiling committee, and both committee chairmen said in the end, we're not going to define ponding because it relates on how much water, where, what the tiles are, how wide the joints were, is the grout sealed, how long the water's going to stay there, what becomes a nuisance, when does it become a health hazard. They go round and round in a circle and they say, we're not defining it, right? But I've put one out that says, look, if it's bigger than about a big dinner plate, about 400 square centimetres, if it's deeper than 1.5 millimetres, which is if it covers a 5-cent piece, or if it's there something like that 15 minutes after you wet it, then I think it's going to stay around and breach the health and amenity part. Remember, this is under the health and amenity part of the code. So you've really got to show that that is affecting the health and amenity. Now, a little puddle right in front of the toilet that leaks from the shower every time the shower's used, I'd be saying that's a defect. It's a real loss of amenity, right? But if you've got an ordinary floor less than 1 in 100 and you pour a bucket of water on it and you find that there's a bit of a puddle behind the door, I don't think that's going to be a defect. So I suppose I'm saying try to justify your position so that if someone comes at you and says, well, where's the real loss here, you've got an answer. Just a quick one on efflorescence too. The changes to the Guide to Standards and Tolerances 2017 has changed this. I think it's a change for the better, but it actually puts a lot of work back onto you guys, because easily the quickest thing to do is say, there's some white stuff dribbling down over there, that's efflorescence, defect, next, onto the right. Now, what it says there, which is the same horrible, pretty much the same horrible wording, but with the sentence in yellow in the middle, that efflorescence is a defect. It may be considered a defect if it is due to defective or missing flashings, membranes or damp-proof courses, or faulty design, and needs to be investigated, identifying the cause, to identify the cause. So in other words, you've got to say something about what caused the efflorescence. rather than just say there's efflorescence, there's a defect, let's move on. And the other thing is that...
What's your comment on the Queensland guide sense and tolls with respect to that same clause?
I'm not familiar with it. I mean...
It says it happens in the first 12 months, it's a defect after that, it's not a defect.
Well, that'd be taking it back into the realm of maintenance, and that's actually what I'm going to talk about now. There's a couple of issues that come up.
Just quite different.
Yeah.
Victoria, New South Wales.
Yeah, ACT. So, efflorescence traditionally wasn't even in there. The only time it ever came up was discussed, and it is mentioned in the AS 3958, the tiling code, but it was never called a defect, and it's traditionally been a maintenance issue. But if we have bad design, it really makes it very bad, and I think it is a defect. But saying it's a defect in all cases is not right, because in some cases I don't believe that it is a defect, right? We can't avoid some moisture getting into cement and that moisture coming out, and when it comes out it brings a bit of calcium hydroxide with it. Right, so I think some of it's unavoidable. You should look at this if you're going to be doing some assessment. You look at it and say, well, where are the wastes? What are the falls like? I had a bad one at Walleye Creek where the outside paving, the concrete sloped towards the door of the gymnasium, and the gymnasium had an awning over it easily the size of this room, and all the efflorescence was forming over near the doorways, which was well in under where you'd ever get any rain. And what was happening, the rain was falling outside, hitting the concrete, moving along the concrete fall to the front of the doors, then rising up as it dried out and bringing all the efflorescence. So the efflorescence wasn't anywhere near where the rain was falling. It was a long way away. It's a design defect. It had to be looked at that way. So sometimes it is and sometimes it isn't. Stairs are a wicked problem. It's very hard to not get efflorescence on stairs because the water gets in and it does carry down. So we've been using drainage cells and a few things like that. Put a water stop angle on the top step, so you've got a big deck. It doesn't all come down the stairs. A few issues. So I think you need to actually contemplate it and put something into your reports that says, I believe that the efflorescence has been caused by, and name someone. Cleaning and sealing can sometimes address this issue, but like I've said, it's always a case of is it maintenance? You know, sometimes buildings get older and a bit of efflorescence comes out. Clean it off. If you stop water getting in, you don't get efflorescence out. So cleaning the efflorescence off, sealing the surface, they're very good ways of limiting it. And we've had an increase in the use of additives in the mortars. I see Barry sitting up the back there, and products like F-Lock and CR25 and the like are being added into the mixtures. I think that they work, right? I don't know if they work in all situations. Our trouble is that the porosity of tiling mortar is very porous. We can get really good results in dense mixtures, but with tiling mixtures is a bit hard. But I'll hand over to Barry on that. He can talk about it a bit more, I'm sure. Then the other thing that's coming up is latex leaching. And if you take a look at that slide, it's a pretty shocking look. Now, it's a problem that's becoming more common, and I think it's because we're double membraning more often, so we put another membrane over the top to stop the efflorescence. And if that tiling is open and it rains, they haven't had a chance to grout it. If it rains a day or so after it's laid, but before it's grouted, then all the water gets down, and it gets into the tram lines of the tile adhesive notches and the like, and then the tiler grouts it in and the water's locked in underneath. And then we get some reactions with some of the products that are in the adhesives, and then that starts to bubble out. And so when we take a look at it, it's a pretty different looking beast to ordinary efflorescence. So you'll be able to see the little bubbles. We get little volcanoes. Sometimes it's clear when it gets a chance to dry out, right? And it is something that's coming out of the tiling adhesives and grouts, right? And it's very hard to treat. We're finding it's very difficult to get rid of. So if you see some white stuff on the top of the tiles, it may not just be efflorescence. It could be efflorescence mixed with latex, which is going to be a problem. We're cutting out the joints, leaving it dry for days and days and days, blowing water out of it, all sorts of things to try to get rid of it. I'm going to hand over to Christoper now, and he's going to take you through a few problems that relate to stone and tiles, and then after that we'll be able to have a chance for Q&A.
On the drummy tiles, what percentage of the tile has to be drummy to be considered a defect? Is if you have 20% drumming, is that a defect? Or if you have 8% of the tile drumming, is that a defect? What percentage of that tile is drumming?
Right. Once again, I think it takes analysis. What's in the Australian Standard 3958 is if more than 20% of a tile is sounding hollow, it should be considered suspect, right? Depending on whether it's on the wall or the floor, right, and the level of use, and that's what it says in the standard, right? And I kind of agree with that. If I've got 20% of a tile that's drummy and it's right in front of the fridge, I think someone's going to drop a bottle of Coke on that, and it's going to, well, not today's bottles of Coke, but a bottle of champagne. The old Moe goes on the floor, you know. If they drop a bottle of champagne on that, it's going to break, right? So if it's right in the middle of somewhere and it's only 20%, I'd be saying, well, I'm a bit worried about that. But in this case, cut the joint out, pump some liquid under it, regrout it, and probably leave it there rather than try to chop one tile out, have the disruption to all the rest of the tiles, not match the grout, etc., etc., etc. So if it's in the front foyer of a hotel, it's going to get a lot of traffic. It's going to get hammered. It depends on where it is. So look at that. Look at it, wall or floor. How much traffic is it going to get? What's the option for fixing it? Yeah, that's right. Yeah, I think you can apply logic to it and say, well, it's going to be fine. Yes. All right, Chris.
Morning, gentlemen. As Colin stated, my background is tiling with an emphasis on stone maintenance and care. Today we're going to look at some of the defects and addressing the issues we have with stone. It's similar to tiling, but the difference is generally the stone is what's affected as well as latex leaching, efflorescence, and seeing those kind of issues. The stone seems to get compromised because it's not a non-porous inert material such as a ceramic tile. The common problems we look at are cracking, scratches and chips, poor laying procedures, blending of stone seems to be an issue, salt attack. We're seeing more and more of that around getting limestones and low to medium porosity stones getting used externally. A lot of these issues can be rectified. The issue we have is there isn't a set guide or standards to follow regarding stone or stone maintenance. It's just good industry recommendations and practices. There are guides such as the Australian Stone Advisory Association's design manual for stone, but it really comes down to just the tradesman, his level of skill, and what can be achieved. Stun marks are a difficult one, as generally with stone we can repolish, as the second paragraph states, using epoxy fills, and we can, especially with the advent of the new products epoxy-wise, that can really take care of a lot of the issues that previously we couldn't regarding cracking, pitting, chipping. We can often get a seamless finish where years past we couldn't. Stun marks generally go deeper than the polished surface of the stone, so even when stone gets repolished, it may still be evident. And the difficulty, I suppose, is you have to look at stun marks generally can come when the stone is in its slab form before it has even been manufactured or used as a tile or a panel, but also can come from impact, stun marking from dropping of, as Colin's mentioned, a champagne bottle, things like that. Salt attack. This is a more and more prominent thing. This is a slide shows some salt attack on some lava stone. Very difficult to maintain and prevent. There are sealers and maintenance programs we can follow to try to mitigate and prevent these occurrences. Picture framing and bleed through and water bruising of stone is a very, very difficult one to handle. A lot of these stones, such as the Carrara you see in the slide, the images, are used in wet areas, and if not treated properly, can result in some water bruising where water has penetrated through the grout or into the substrate, and it isn't able to come through the surface adequately, so it leaves behind a water stain. Now you can see the poultice that's been used. There's various types of poultice. The simplest one can be bleach, really. A bleach rag soaked can remove a lot of stains, rust, things like that, if you test an area, obviously, so you don't burn through the stone, depending on the type of stone it is. But that can be a simple one. This one is sodium metabisulfite and sodium hydrosulfite with diatomaceous earth, which essentially will draw out stains. But as you notice from the image, we can get rid of the stain, but we can't get rid of the water bruising. Issues like this can be looked at as a failure in possibly the stone system that was used to install. That is pre-sealing adhesive. There's a lot of contributing factors that go towards achieving a seamless stone installation. Staining from tile adhesive being spot fixed. Now this one, Cole, if you can help me out, there's two, we've got this.
Yeah, well,
so that one and that one. Which one was removable? The dark spots or the light spots? I can't.
I think it was the light spots that were able to treat.
So the poultice that we applied before can be applied on walls, and in this instance, the light spots were treatable. So in normal cases, if someone was unaware that a poultice could be used to remove this, you'd condemn the entire installation and say, well, you've got spot bleeding, so the whole thing needs to be removed and replaced. But in this case, guess what? We can remove half of it, and the other half gets removed and replaced. So depending on the size and scope of the rectification work, you could save someone a lot of money or a lot of time by just having a qualified stone tradesman maintenance specialist to remove this kind of thing.
Shove over. Just on that one, because I think it's important, that doesn't show up quite often for months after the tiles are laid. So what's happened is the tile has dot fixed the adhesive onto the back of the tile. Now, dot fixing with stone isn't banned, but it comes with problems like this, as you'll see in the next couple of slides too. So they did 20-odd bathrooms before this problem became evident. Right, and nobody's going to say that's acceptable. Fine, I'll pay for the unit. So it's a big issue, and we end up covering the whole back of the stone with adhesive and then spot fixing it if we want, because at least then the whole of the tile changes colour at the same rate.
Same issue we can see here as previously. This is an external sandstone wall. I think there's about 4,000 metres of it totally, and you can see the mould spots coming through, and you can see the circles determine that this sandstone was spot fixed. So obviously there's some moisture penetration and migration that's gotten through. The waterborne, the particles have seeped into the adhesive, and mould is coming through from the wetting of the stone, the sporadic wetting from either the dew in the morning or the rain. You can get this kind of effect, and as Colin mentioned, possibly back buttering the entire tile, because these tiles weren't back buttered in this instance, may have prevented this, because the entire tile is now coated with adhesive. You're essentially creating a second layer, so it's a uniform system. Low density limestone with water bruising. As I mentioned previously, we're using different types of stone for installations that may not necessarily be recommended previously. Low density limestone is a difficult one because of its level of water porosity and water absorption. So if not treated correctly, you can achieve this level of discoloration. And I'll work on Colin's point of poor substrate fall. This could be a case that can be attributed to poor fall in the substrate, possibly, where the concrete isn't sloping to the floorway, so you've got a ponding area where if the grout is porous or water has penetrated through and the tiles weren't sealed, for example, it can get through to the substrate. The substrate will stay permanently wet as the shower gets used, and when the shower isn't used for a day, 2 days, 3 days, whatever the time may be, as the water tries to leave the system, it gets trapped, and the limestone is discoloured permanently as a result from...
if there was a working water stop there, it may have just discoloured in the shower.
Yeah. So, and that's a determination you have to make is, well, okay, what constitutes a seamless installation? Does a water stop in the shower? It's slightly darker than the main floor. Does that mean it needs to come out, or is it an acceptable situation? Yep.
Well, that's a really curly one. I've been there that many times I wouldn't care to remember. The code says that if it gets out of the bathroom, it's a defect. So theoretically, getting out of the shower and into the main shower floor doesn't make it a defect, right? And if this was ceramic tiles, you wouldn't see it and nobody would know it, and everything would be fine. This shows you that water stop angles work, right? It would have kept the water inside that shower. The revision of AS 3958 in 2007, I managed to get a clause in there that says, consider that if there is absorbent stone being used, that the water stop at the door of the shower must work, right? So clause 213, whatever. And so in this case it was deemed that that's defective and it was replaced.
And with water stop or not, I suppose that would constitute an aesthetic defect. Even though the shower might still serve its purpose, it's aesthetically not pleasing to the eye anymore. Yeah, Dale?
The difference in the tiles here, front near the door, and that's clear that.
Yeah.
What are you doing?
I believe that was a repair. When they first started to complain about it, they went in and patched a few tiles, and then it still kept on happening, and they got me.
No, that's something we'll look at soon. Like I said, ceramic tiles you can often find even with different batches. The variation is slight, and you can generally, it's close enough. You can get a 90% of a match, whereas with natural stone, 2 different batches, same quarry, different part of the mountain or quarry that it comes from, you can get batch issues, and that's something that's very, very common. Cryptofluorescence picture framing in granite. This is a difficult one to treat once visible because granite generally doesn't need to be pre-sealed. Depending on the system. However, this is water penetration because the granite is non-porous and it's leaving behind the efflorescence, but it's not manifesting through as white powder, it's manifesting through the joints, and it'll permanently have this wetting effect and wetting look. And once they're even cutting, we've had experience trying to retrofit and cut joints and allow drying and allow the moisture to come out, and some parts of this will disappear, but a lot will remain, and it's a very, very difficult one to have any kind of scope of rectification that you can guarantee will last. Generally it needs removal and replacement. Now moving on to sealing of tiles, which is quite a difficult topic, seeing as there's really no standard or specification for sealers or any requirements for sealers. It's generally on a manufacturer's guidelines or stone supplier's guidelines and what they recommend. Different types of sealers. We've got silicates, water glass, which are hydrophobic types of sealer. They usually apply wet-on-wet application and require a significant amount of curing time because the essence of a hydrophobic sealer is to penetrate and change the actual structure, filling all the pores and all the holes in the stone, the micro-cracking in the stone where possible, to create a hydro-repellent effect. So the stone essentially repels water. So these need a 6-sided sealing. True hydrophobic sealers don't impede bonding of adhesive. So if you're looking at a hydrophobic sealer, that's one question to ask, because if the manufacturer says that, we don't recommend 6-sided sealing, then I would not think there would be a true hydrophobic sealer because they shouldn't impair the bonding. Silanes and siloxanes and fluoros, these are quite water and oil resistant because they generally are a silicon or Teflon based sealer, so they're essentially a type of coating that will repel for a time, and then after, obviously all sealers have what we call a dwell time, which is a contact angle where if you were to drop a bead of water on top of the sealer, you might see the bead would be a spherical shape for a time, a certain amount of minutes, hours, depending on the quality of the sealer, age of the sealer, and the environment that it's installed in. And the dwell time, as the time passes, the sphere would slowly go flatter and flatter and flatter with a larger contact angle, which shows that the water is slowly penetrating through and breaking through the resistance of the sealer. Some issues we can have with silanes and siloxanes is that they are coatings and essentially non-breathable. So if you've got a stone that needs to breathe, or if a substrate that is quite damp or holds a lot of moisture, and you prevent the evaporation of this water and the breathability, that's where we can get issues, as you've seen in the shower recesses, discoloration, because the water breaks through the dwell time of the sealer, gets through, and then once the surface dries, the Teflon and the silicons are doing their job again, but they do it in reverse, and the moisture cannot get out, and you can get a whole lot of issues that come from this. And again, that's just through experience. It's very difficult because there are no real test methods for breathability yet that have been prescribed for companies to sell sealers and things like that. Water-based epoxies, very successful because essentially you're turning the back of the tile into an epoxy-coated system. You can liken it to a ceramic tile. It's a 2-part water-based. You paint on the back of the tile, and essentially the back of the tile becomes inert because you've covered it with epoxy. So now no waterborne particles, moisture from the adhesive or the screed layer can penetrate through the stone. So a combination of these things is successful. A 6-sided seal plus a water-based epoxy will prevent a lot of these issues because you're making the tile as inert as possible so that it doesn't get affected by any environmental factors or grouting issues or adhesive issues or any of the issues we generally see with stone. Stone defects and assessing the suitability of stone. Fit for purpose environment, that's a difficult one because a lot of stone can be used if installed correctly with the correct maintenance regimes and installation guidelines in terms of adhesive sealers. So, as I said, guidance is available from data sheets and test results, and generally a good conversation with a specifier manufacturer can give you a good idea as to what requirements may be needed to install this type of stone. But a lot of it becomes quite onerous because a lot of stone installations require maintenance, which is something that seems to fall by the wayside. The stone gets installed, as we said, we saw the liability periods after 12 months. It's your problem to take care of, and we often see latent issues coming up 1 year, 2 years, 3 years after the stone has been installed. Should 6-sided pre-sealing be called for, and was spot fixing banned? As Colin mentioned, spot fixing isn't banned in stone installations, but more and more we're finding that, in my experience, spot fixing, the issues we see with spot fixes is when there's such a large size tile and there's only a small amount of spots. So I think coverage is an issue when it comes to stone installations. The more voids that you're going to have is the more likelihood that you're going to have an issue with it because you're allowing more moisture penetration. So even though spot fixing can be used on stone, it should still be treated that you're trying to achieve a high level of coverage to prevent any water. We're trying to create a system that is watertight. Back buttering of stone tiles. On ceramics, the general recommendation from adhesive manufacturers and AS3958, the guide to tiling, is any tile over 300 by 300 in size requires back buttering. Now, this holds true for stone, but also depending on the stone, the slide with the Carrara with the poultice on it, if it's a Carrara tile, a lot of the time they're subway size tiles getting installed out of natural stone Carrara. Adhesive manufacturers will recommend even small tiles, 100 by 200 millimetres or 250, be back butted for the purpose that you get water bruising and bleeding issues and penetration from the adhesive through Carrara. So small tiles that would generally not, if they were ceramic, you wouldn't consider back buttering them, need to be back butted by adhesive guidelines. Again, maintenance has been adequate. When it comes to sealers, there's a lot of sealers out there that offer a 15-year warranty and the like. The issue with these is if you read the fine print, that's conditional on the sealer performing. So that could be every 3 months, it could be every 6 months, this sealer may need to be applied. And my argument is, okay, it's like a car. If you wash your car every day, it's going to stay clean for the rest of its life. But with a sealer, it's hard to kind of ask general homeowners to perform this test and to have a sealer reapplied every 6 months, 12 months. So one of the points to be made is, when it comes to stone installation, is we need to assess and create a system. Just sealing a stone and allowing the adhesive, the installer, to spot fix with 3 or 4 dots, allowing only 30 or 40% coverage, isn't going to solve any problems. There needs to be an effect and cooperation to achieve a system that means we can use any type of stone for any purpose and it will succeed because the system has been followed as per all recommendations. When we assess stone defects, can it be treated or has to be replaced? As I stated before, chips and scratches, things like that, I believe in many, many cases can be fixed, whether it becomes from just an epoxy fill or if the surface needs to be grounded and repolished. Honed stone, for example, limestones and marbles, there's a very, very high success that repolishing of a honed marble will result in a seamless finish without needing removal and replacement. Polished stone is a little bit different because the lighting angles and how everything gets affected, unless obviously we do a complete repolish of an area where an entire floor gets repolished as a whole and then it results in a uniform finish. As Colin mentioned with ceramic tiles, cracked floors, we're going to replace a cracked floor and put one down. Is it going to crack in the same way? The same applies to stone. Will replacing it result in success, or are we going to see the same issues occurring, or does a different approach need to be taken? Design faults, specification fault, construction fault, again, it all comes back down to the system from cradle to grave, where the stone has come from, its recommendations for treatment prior to an installation. Granites, for example, true granites, A lot of the granites we see now have a basalt component to them. They're not a true granite, so they have a little bit of moisture sensitivity, which causes a few issues, such as the cryptofluorescence. True granites don't necessarily need pre-sealing. For example, a good installation procedure and a post-seal with good products is enough to maintain a granite installation. But if there is a few, questions that arise from potential problems with the material, not problems per se, but just general issues or concerns, a pre-sealing system may be adopted. I think Colin put this photo, which is quite succinct when it comes to stone. That's sort of what we're looking at. It's a very, very open kettle of fish. You can talk for hours on the issues, because stone that we saw, 5 to 10 years ago with minimal issues are now showing issues in installations where we haven't seen before. Every day you look at different stone installations and see something new that you'd never think would happen on these types of stone. So it's the progression of products that we have. I think we've got some great products that have progressed to try to minimise maintenance and minimise issues, but without the right knowledge about how to use those products and how to combine them with a system, we're kind of double dutching ourselves, and we're finding a lot more issues coming out of stone installations. So, any questions? Yes?
For the marble floors in bathrooms,
Yep.
green stone that comes through the marble,
Yep.
would that be treated?
Yes. Generally, green staining from mould, things like that in marble. Yep, because it's natural material with micro cracks. It has a level of porosity, so it can hold water, mixture of your soaps, cleaning things, which all contribute, and essentially mould can grow. There are products that are part of a maintenance regime where they're mould removal, so depending how the extent of the mould, you can remove it, and some of the products actually are retarders, where once the mould is removed, they will retard mould growth for a time. So I've seen on travertine, for example, the whole bathroom, not an issue, just one tile in the corner, mould keeps coming out of one tile, and they, without changing the tile, we applied a mould removal solution. It was just a bottle and a spray. It's quite simple. Gave it to the owner, and she said she didn't have to wait. Had to wait 12 months before needing to reapply this spray. It retarded the mould for 12 months. So even on a small scale, depending on access, removal of one tile could take 4 hours, or plus you have waterproofing issues to consider and all the things when you consider removal and replacement in a wet area. This was a simple fix where a bottle of solution has done the trick, and she can maintain it as she cleans once a year and doesn't have to worry about it ever again. Yep.
Waxing tiles, explain why, how, and when it's done.
Waxing something that, for two reasons. Wax is a repellent, oil, water. The issue with it is it needs to be reapplied depending on the quality of wax. Generally, we can use some systems such as Sydney Airport, the first class lounge, a business and first class lounge for Qantas. The specification on that was a 2-component sealer, 5 coats total, and they use a polished statuaria marble, and to achieve the slip resistance rating, they had a specific wax that needs to be applied to this floor, so they can have a high polished marble that achieves the slip rating required to be fit for purpose. So I'm not sure of the actual maintenance regime or how often that wax coating needs to be applied, or if it is reapplied, but that's one aspect. And also we can wax terracotta tiles to enhance their properties. There's different levels. You can have low lux wax, medium and high lux, so you can have waxes that exhibit a high gloss to really bring out the shine in the surface, or you can have a wax to just bring out the character. So it serves a practical purpose as well as just an aesthetic purpose, just to liven up a material if needed. So, yep.
3958.1 is for ceramic tile.
Yep.
There's no code for stone.
No.
Would you recommend 3958.1's guidance in relation to perimeter and inverted control points?
To an extent, yes. Stone, this is the thing, 3958.1 is currently looking at being revised, because the perimeter and control joints apply to extruded and dust pressed tiles, which generally have a higher thermal coefficient of expansion than the tiles we see today, porcelain tiles, which are essentially inert and don't grow, is the word I'm looking for, compared to the tiles we used to use, the biscuit, twice fired biscuit back tiles with the glaze. So, yeah. So, and with stone grows less than ceramics, by definition. And with stone, as there's no specification for joint sizing, the stone installations get done generally with tighter tolerances, 1 millimetre joints. You still have to use your perimeter joints, obviously. Crack isolation system that Colin mentioned. Yeah. No, there's no code. So it comes down to as you look at the size of the installation and the location of the installation, and you can, in my experience, I have seen it stretched where it doesn't always need to apply that the 4.5 metres externally in direct sunlight has to be observed. You can go further. Possibly with stone we can achieve like soft joints, for example, where instead of using an actual mechanical expansion joint, we leave a 3 or 4 millimetre wide joint in the stone and use a silicon or a polyurethane to treat it. Another issue, again, this photo's precise, where you use the wrong types of silicon sealants on natural stone, you can get bleed from those sealants. There's a few sealants that are guaranteed for natural stone. Others, normal neutral cure silicons, I would not recommend with natural stone for their propensity to bleed through the actual edge of the stone. Another option for expansion joints, for example, is to treat the installation as if you were putting an expansion joint through. So clean the joint, make sure it's clear and movement can occur, and then grout it. Backing rod and grout the surface. So it's a seamless finish, and at the very worst, what you'll see is a hairline crack appear through the grout if movement occurs. If that's the case, then you go, okay, we remove the grout and replace it with a silicon sealant. But until that happens, I've seen it and personally have performed it where I've grouted an entire floor, left an expansion joint, grouted it, and there's been no movement. So it's still functioning as an expansion joint because the grout's only a 5mm penetration. And if there was any movement, you'd see a crack along that grout, and then I'd say, okay, it was done as an attempt to minimise any visible expansion joints for the client. So that was just an agreement made to take that approach. So it can be successful, but it cannot. Same as in a ceramic tile installation. Train stations, for example, you can put perimeter joints and movement joints at the requirements and specifications and still have cracking and issues because the extraordinary amount of movement. At the end of the day, the AS 39580 is a guide to installation of ceramic tiles. Yep, definitely. Yep, obviously, yeah. Anything else? Yes.
I've got a question for Colin.
No problem.
And it affects drumming tiles. And the question I have is what is the long-term effect of drumming tiles? And I say this because I have a bathroom that was built in 1968. I purchased the property in 1979 and it had drumming tiles on the bathroom shower hall. 2018, those tiles are still there. And they look like they're going to stay there, but they're all gone.
Yeah. That actually reflects what I said earlier, and that is you need to look at what's the impact of the drummy tiles, the likelihood of what's going to happen if it does go on and fail. In that case, you take a risk, you leave them there. If someone has to do a repair, then they'd be able to maybe save those tiles, cut them off, glue them back on, or if you had a hob that was a different colour, no big loss, right? But if it's a large area in a foyer, and I come back to the question before that what's happening, the technological changes in the tile industry are really speeding up now. I've got a photograph of Chris in Spain in front of a tile that's bigger than that panel there behind you, right? 3.4 metres by 4.8 metres by 1.68 metres A1 tile, right? How do you pick it up? How do you handle it? It's about 5 millimetres thick. It's still a 3-man lift. Turn it around, hold it on its edge, it bends in the middle and snaps. And you've just thrown away $1,000 worth of tile. So these things are happening. They're making them, and we almost can't use them. We've also got issues with exactly that. Tiles have been getting bigger. You know this. Wherever you go, the tiles are larger and larger. The joints, they want them smaller and smaller. So therefore, where does the expansion take place? In the old days, small tiles, lots of joints. The joints were wide. The joints can take up a bit of it all, right? So we're getting ourselves into a very threatening situation here where the sandwich layers that make up the tiling system are under threat from the actual tiles on the top. Even though the tiles are basically inert, if they're in the sun, they're going to grow. And they're going to shrink then over night time. And if we don't accommodate that movement, we're going to get movement in between the different layers that will cause failure. So I'm seeing it. The other thing that I'm very wary about is movement joints that are made by the major manufacturers. There's quite a few companies that make metal edge neoprene filled joints, and they Latham is one of the really good guys in this, very good quality product, and they put out the data. And if you dig down through their data, you'll find at the back of it that they say that their 6mm wide neoprene filled metal edge joint is capable of taking up between 16 and 20% compression. Now, if you've got a 6mm joint and it takes up 20%, that's going to be 1.6 millimetres, right? That's it. And then another 5 metres later, you've got another one that can take up just over 1.5 millimetres. And another 5 metres later, you've got another one that can take up 1.5 millimetres, right? So that isn't a lot of accommodation. I would basically never specify them at 6. I always go to 12. And there are companies out now we're getting some good German product in, which is really quite flexible. It's almost a 6-way movement in these joints, because the neoprene is put sideways and not vertical, so it'll stretch, it'll move up and down, it'll change, right? So these joints really work. You can have them at larger distances. So the whole thing is how often, and nobody's done the data on it, how often do we go if we say, all right, we've got big tiles and they're, say, 750. If I put a movement joint every 1.5 metres and it's only 1.5 millimetres wide, can I get away without doing movement joints in the whole job? Because I've got lots of little ones that look like grout joints. But I haven't seen the empirical data that will show that that's going to accommodate the movement properly. But to my mind, logically, it would. So you could get away from some movement joints by having more movement joints that are narrower.
Colin, the latest leads to a situation where you've got a double membrane coming out of the things. You said it's very difficult to fix. Have you had any success?
Basically, I haven't. What we've had to do in a few instances where it's been really quite bad, and the reason I ended up getting onto the track of this, it was happened in 2 apartment blocks, one at Bondi and one at Drummoyne, and the apartment blocks were built and tiled, and tiling was taking place, and some of the decks got rained on before they were grouted, and they were the ones that had the problem. On those decks, what we've, after, in one case now, 2.5 years, we're still trying to fix it, and that's cut out the joints. They tried to cut them out and put in epoxy because of the strength of the tile and the strength of the epoxy, but when we get water vapour pressure building up under the sun out on the deck, this goes past it, and so it still pops out somewhere else. So epoxy grout didn't work, and the only thing seems to be to try to allow the products that have been dissolved by the water under the tiles to coalesce again. And you'd probably be able to help me out a lot more with your knowledge of what's going on with the coalescing of these products. But cut out the joints, blow out the water, see if you can keep it dry for days, if not weeks, and then re-grout it with one of the new grouts. The grouts that most of the big companies have got, Latacrete, Davco, Bostik, they're all going for designer level grouts. Very, very, very fine. Huge improvement in grout in the last 5-10 years for the high-end grouts if you pay for them. And one of those grouts is probably going to allow a little bit of breathing and a fair amount of strength. But we almost can't fix it.
What's your preference in relation to membrane? Do you prefer not to use membrane across the screens, or rather the other way?
All right, I'll just repeat the question. Would I prefer to have a double membrane system or not? Look, a double membrane system is not necessary if you take all the precautions beforehand to make sure that there is good fall in the floor. If we go back to the way the old tiles were laid and we didn't have a lot of efflorescence, it was a little bit to do with the cement, but a fair amount to do with the fact that the concrete sloped the right way or sloped towards the drain, so water that got down through the grout joints and got into the bed and dissolved the calcium hydroxide moved sideways and down the drain. It went to Bondi or Manly or wherever your sewage outlet goes or stormwater goes. It might cause a bit of a crust down the drain, but it didn't come back up through the joints. When we've got poor building practice and the slope in the underlying floor runs the wrong way, then we really do need a top membrane, because even if that membrane doesn't stop water getting through, it just stops the evaporation process, the water vapour coming to the surface at the grout joints and bringing the calcium hydroxide, which then deposits on the top of the tile joints and gives you the white crust and the dribble marks over the front. So double membranes do work when it comes to limiting efflorescence, but they're not necessary if you've got good falls in the substrate.
Does the efflorescence ever stop?
Yes, it does. It's finite. Most people say, "Oh, was it washed sand? Where did this come? Is it salts from the ocean?" Well, it's not. It's not ocean salt. It is calcium hydroxide. It comes as part of the setting process of the cement. Barry will fill you in all the details of this. It becomes 15 to 20% of the whole volume of a concrete mix when it sets. So in fact, it's part of the crystal growth stage of cement, and they are part of the crystals. The trouble is that they are soluble, and they don't interfere with the strength of the cement when they disappear. But when they get wet and they migrate, that's the one that comes out. Once it's all come out, you won't have efflorescence. And the classic case, and I've looked at this quite a number of times, is where we've had a breach in a water stop angle and the fall in the floor is going the wrong way. And I've found efflorescence out in the bathroom floor, but there's no efflorescence in the shower. And that's basically because the shower's used every day. The water goes down, it dissolves all that calcium hydroxide, takes it down the drain in the shower, it's gone. But the little bit of water that's getting through and coming out and drying upwards out in the other part of the bathroom, that's not enough water to wash all the calcium hydroxide out, and so it's still coming up. So we've got efflorescence outside the shower and no efflorescence inside the shower. It's gone, it's a finite thing. But getting enough of it washed away on an ordinary deck, it's a bit difficult.
There's different types of cement, isn't there? I mean, we've got 4 different brands of cement.
Mm-hmm. Yep.
They all have different characteristics.
Yep. The big change came when Blue Circle took over. Barry will tell me all about this. 1991, okay. We've carved that into the memory. The Australian cement manufacturers, Candos and all those guys, they were making very good quality cement. And Blue Circle came in and said, no, the international standard is there. And so they started to make to there. Everybody had to compete, so we all made to there. And that meant that we had built cement in general purpose, and we're getting various things that are happening with that. We lost the high early strength. Quite a few things changed when the cement changed, and since that day we've had a lot more efflorescence issues. It's a bit hard to repeat all that for the camera, but Barry knows his stuff, and I'm sure you'd get him here to talk about it sometime. Yeah. All right, thank you very much. Chris?
All right.
Any other questions?
Just one last one. With that stone bathroom there, the water, the bruising, how did you end up with it?
Replacement, isn't it?
That one, it came out. All up.
And the rectification, what did they do to change it?
The double membrane system. And a different stone. Just really quickly, limestone under ASTM measurements and generally accepted worldwide comes as high density, medium density and low density. That's because the White Cliffs of Dover are chalk. That's limestone, but also we can get some very hard black limestones and things like that. It's a very widely varying stone, and so the different water absorptions are the keys, and only high density limestone is recommended in wet areas, and I'm then still suspect about it. And you won't find in a tile shop, you go there, they won't tell you whether it's high, medium or low density limestone. It's lovely, it's limestone, buy it, and you've just inherited a problem.
It's a limestone,
Sorry?
lime.
Yeah.
you very much. That was great, Colin and Chris. Very informative. The